All right. In this example, we're asked to use the fact that systolic blood pressure readings are normally distributed. We're given the mean and the standard deviation. So we're given a mean of 121. So X bar is 121, and my standard deviation is 15. And we're asked to find the percentage of individuals who have readings that are below, above, or between different values that we've been given. Now, what we need to do here, this is a copy of the table that you'll have on the file, and it's taken directly from your textbook. I've reprinted it and had retypeset it, but it very closely resembles what's in your textbook, so that hopefully it's something you're familiar with and have seen before. Now, the whole idea here is that those percentile calculations are very, very difficult, borderline impossible to calculate. And so what we can do, rather than calculate those percentiles for every distribution that we encounter, we can take our distributions and we can rescale them to the standard normal distribution, which already has these percentiles calculated. And so once we convert our data to the standard normal distribution by calculating what we call a z-score, then we can look up the percentile of that z-score. And remember, percentile is the percentage of the distribution below that value. And so for 142, what we're literally asking is, what is the percentile of 142? Well, I need to convert 142 to the distribution that this table was calculated on. I do that by calculating my z-score. So the first thing I need to do is find out what is the z-score of 142. And so I'm going to just call it z142. And I do that by, well, my z-score formula, I'll write it up here. Z-score equals my x value minus my x bar, my mean, divided by my standard deviation. I need to remove the mean because my standard normal distribution has a mean of 0 and a standard deviation of 1. And so I need to remove the mean from each value by subtracting it. And then I need to rescale the result so that the standard deviation is 1. And that's why I'm dividing by the standard deviation there. All right. So to calculate this z-score, I'm going to have 142 minus 121 divided by 15. Okay, so 142 minus 121 divided by 15 is going to give me a value of 1.4. So I have a z-score of 1.4. It's positive because it's above the mean. And so I go and I find on this chart, I find 1.4. And on this chart, it tells me that 91.92% of data falls below that z-score value. And so from table, 91.92% of readings, well, really of our population, of the population falls below see if I can do that a little bit worse, below, and then this is my my reading of 142. So has blood pressure below 142. Okay. Well, that doesn't seem so awful. Let's try above 133. First thing we got to do is calculate the z-score. So we still need to rescale our values, but the above is going to be different than the below, and we're going to have to think about that when we get there. And so I've got a z-score of 133 that I need to calculate. And that is going to be my 133 minus my 121 average divided by my 15 standard deviation. All right, so I have 133 minus 121 divided by 15, and I'm going to get a value of 0.8. And so I'm 0.8 standard deviations above the mean, so 0.8. And so if I find my 0.8 standard deviations above the mean, my z-score is 0.8 on this table here. I get that 78.81% fall below that z-score. Well, I can pretty quickly find out how many fall above that z-score because, well, total is 100%, right? And so if 78.81% fall below, well, then the rest of it falls above. And so the rest of that 100% falls above. And so 100% minus the 78.81 will tell me what the percentage above this z-score is. And so what I'll do is I'll take that z-score implies percentile is 78.81. The percentage above 133 is 100 minus 78.81%, which would be 100 minus 0.81 be 2119. Okay. Now let's change it a little bit more. Let's think about between two different values. So let's find between 112 and 130. Well, I'm going to need a z-score for each of those. So I'm going to need a z-score for 112. So I'm going to need my z112, and that'll be 112 minus 121 divided by 15. And so that'll be 112 minus 121 divided by 15. That'll give me a negative 0.6. And then I'm going to, we'll use blue, I guess. And then I'm going to find my z-score for 130. And my z-score for 130 will be 130 minus 121 divided by 15. All right, so now I've got 130 minus 121 divided by 15. And that'll give me a positive 0.6. So 0.6. And let's think for a minute about just what we're trying to do here. Let's go back to this idea of I've got a normally distributed bit of data here, right? Well, a normally distributed population. It's going to follow that bell curve that looks like this, and it's got my mean here, which is my x bar. And what I'm really finding here is that if that's 1, and that's 1, that's 1, and so that would be minus 1, that would be plus 1. What I'm really finding here is that at negative 0.6, I shouldn't use blue. Let's use black, because that's what I used for that z-score. So if that's 1, then that'll be at negative 0.6. And then this will be at positive 0.6. I have these z-scores, right? And then based on these z-scores, I know what the percentile, which is the area under this curve leading up to that negative 0.6. And then I also have, for my 0.6, I also have a percentile, and that's this whole area. That also includes the area covered by the negative 0.6 percentile. And so what I'm really looking for is the area between those two readings, right? And so the way I'm going to find the area between those two readings is I'm going to take the blue area and I'm going to subtract. So this entire blue area, and I'm going to subtract that black shaded area from it. which will just leave me with the area between those two purple lines. Well, that's the same thing as saying what's the percentile of my Z130, which is 0.6. 0.6 is going to give me a percentile of 7257, right? If I go to the table here, I'm finding 0.6, I'm getting 7257 out. And so this is percentile 72.57. And if I go to the negative 0.6 on this same table, I'm going to get 27.43%. And so this will be percentile of 27.43%. And so what I have is the entire space below that is the 7257. The entire space below that is the 2743. And since I'm looking for the space between the two, I'm going to subtract the 2743 from the 7257. And so my actual value, so my percentage between 112 and 130 is that 72.57% minus the 27.43%. So if I do 72.57 minus 27.43, and I get 45.14%. So that equals 45.14%. Okay, let's try a very similar calculation, but with different numbers, just to see if basically doing this again can make it make a little bit more sense, seem a little bit more reasonable to us. Let's bring that down, and I guess I'll bring that down separately just because I need a little bit more space. Okay, so if I'm going to do that, let's also choose my colors a little bit better this time. So I'm going to do a z-score for 145, a z-score for 145, and that'll be 145 minus 121 divided by 15, and so that'll be 140, go ahead and put parentheses, 145 minus 121 divided by 15, and that'll give me a 1.6. So 1.6 for my z-score. And then if I go up here and I find my 1.6 on my table here, I get that's a 94.52 percentile. So that's a percentile of 94.52%. If I remember that right? Yes, I did. All right. Feel good about myself right now. Okay, now let's do the same z-score calculation, but for 157. And that'll be 157 minus 121 divided by 15. And so what's that going to be? I'll have 157 minus 121 divided by 15 will give me a 2.4. And I like this problem because it's, the last one we did was symmetric, and they're not always going to be symmetric. So I think this one's a little bit more realistic of a type of problem here. And so now I've got a z-score of 2.4, and that'll lead me to a percentile. And I need to look that up, right? I need to go up here, and I find my 2.4. And my 2.4 is 99.18. 99.18%. And so if I think about my sketch of my normally distributed data, and if that was my X bar, I'm 1.6, so if that's 1, If that's 1 and that's 2, then my purple line is going to be 1.6, right? If that's 1.6, that's my purple line. And then my blue line is going to be a 2.4. And so we'll say that's 2.4. And that's where my blue line is. And I'm interested in the amount of data between those two, right? So I want the data between those two lines. And so to do that, I'm going to have the area below the purple line and the area below the blue line. And then I'm going to have to remove the area below the purple line from the area below the blue line, right? Because if I shade this in, if I shade in the area below the blue line, it has all of the area below the purple line in it. Then I have the area below the purple line. And so that is this percentile. That whole thing is this percentile. And so what I'm actually interested in is the difference between those two percentiles. And so to find my percentage between, so if I'm looking for my percentage between 145 and 157, I'm going to take that 99.18 percentile and subtract from it my 94.52 percentile. And I'm going to get an answer of, let's see, 99.18 minus 94.52. And that'll give me 4.66%. Which is a very small percentage, but that also seems quite reasonable here because from this sketch you can see that we're well above one standard deviation above the mean, which means we're already talking about smaller percentages to begin with. And then we're talking about a difference of less than a standard deviation, about 0.8 of a standard deviation on a relatively short part of the tail. All right, I hope that helps us calculating percentiles, percentages below, percentages above, and percentages between different data values if you're told that there's normally distributed data and you're given a standard deviation and a mean for that data.